interesting part of our video. In today's video, we'll be looking at past questions from WAEC, JAMB, NECO related to mass and weight. Related to mass and weight. So let's go without wasting time. We are looking at the first question here. Says, which of the following statements about mass and weight are correct? I, weight is the force of gravity on a body. The mass of a body is the quantity of matter in the body. The weight of a body is greatest at the equator. The mass of a body is greatest at the poles. Now let's analyze them one after the other. The first one says, which of the following statements about mass and weight are correct? Weight is the force of gravity on a body. What did we talk about weight? How did we define weight of a body? We said that when you hold a body and then when support is removed, the body falls. And that force tending to pull that body down towards the center of the earth is the weight. So I is correct. The mass of a body is the quantity of matter in the body. Yeah, we define the mass of a body as the inertia. The body, the quantity of matter possessed by the body. That is the body's inertia. So I is correct. Now I says the weight of a body is greatest at the equator. The weight of a body is greatest at the equator. And we are saying no. The weight of the body is not greatest at the equator. Looking at this, we use this, we said that here is our equator. Here is our equator, and we said that this radius at the equator is large. It's larger than the radius at the pole. Here is the pole here. This radius is smaller than this radius. And going by our equation, when R is dividing, now R is greater at the equator, which will make G to be small. And here at the pole, R is small, which will make G to be big. So the weight of the body is not greatest at the equator. So that's not correct. Now, IV says the mass of a body is greatest at the poles. The mass of a body is greatest at the poles. But we are saying that the mass of a body does not change. It's constant anywhere on earth. The mass of a body is constant anywhere on earth. So we have the options A, I and I only, B, I and I only, C, I and IV only, D, I and IV only. And our option, the correct option is A. We go to question 2. Question 2, it says, in the absence of gravitational force, the weight of the body is? In the absence of gravitational force, the weight of the body is? You know that the weight of the body is dependent on the force. And force is mass times gravity. And when gravity is 0, and the mass times gravity will become 0. So in the absence of the gravitational force, the weight of the body will become 0, not its mass. Mass is independent of the gravitational pull. So the correct answer here is option B. The answer is 0, not density, not volume. Question 3. To determine the weight of an object, you could use a beam balance, use a spring balance, find the force necessary, use none of this method, use any of this method. Remember we said the force, the weight of the body is depending on the property of spring. We are using the property of spiral spring, and then that is what we are using here. The spring balance makes use of the property of the spiral spring, and to measure the weight of the body we use spring balance. Not beam balance, not any other option there. The correct option here is B, the spring balance. Next, state two differences between mass and weight. This is the essay part of the question. State two differences between mass and weight. In this question, you are expected to tabulate. You need to tabulate it. You tabulate and then you write mass and then you write weight. And make sure that the difference, when stating the difference, the one you state for mass must tally with the one you state for weight. Like in number one, you say number one, mass is constant. You now say weight varies. If you now say that mass is the quantity that the body possesses, then you must write that weight is the gravitational pull with which the earth pulls it towards the center. So you have the other differences shown to you now. As you go through it, you will record all the other differences. Let's look at question 5. Which of the following statements about a spring balance and or a chemical balance is not correct? The stress is on is not correct. A. The chemical balance operates on the principle of moments. The chemical balance operates on the principle of moment. And what is principle of moment? It's telling us that when a body is in equilibrium, the clockwise moment is equal to the anti-clockwise moment. The sum of the clockwise moment is equal to the sum of the anti-clockwise moment. That is what the principle of moment is telling us. Now, this is our chemical balance. If we drop this weight here, our chemical balance. If we drop, look at it, if we drop the weight here, you see the deflection. And then when we pull this balance, you see the deflection again. So you try to strike a balance between them, and then this is the pivot. This is the pivot, just like this, our knife edge is the pivot here. So number one is A option is correct. B, the spring balance operates on Hooke's law. The spring balance operates on Hooke's law. See our spiral spring. When you add force here, it stretches, and when you remove the force, you notice that it goes back to its original length. It goes back to its original length, and this is Hooke's law of elasticity. So this is our spring balance. Look closely inside. You will see that it operates on the property of spiral spring, and when you draw it and remove the force, it goes back to its original length. So our B option is correct. C option, either may be used to measure the weight of a substance, telling us that either spring balance or the beam balance may be used to measure the weight of a substance, and that is incorrect. You can only use spring balance to measure the weight, and you use beam balance to measure the mass. D, option D says the reading of a spring balance changes over the surface of the earth, measures weight, and we said that weight varies. So the reading changes, correct? And while that of the chemical balance remains constant, mass of a body remains constant. It does not change. It does not have any effect. If a gravitational pull does not have any effect on the mass of a body. So it leaves us with the option C as the answer. This is WAEC 2005. Next question, please. Question 6. A stone and a feather are dropped from the same height above the earth's surface, ignoring air resistance. You have to look at the stress there. It said ignoring air resistance. Ignoring air resistance. That is in a vacuum. When you drop the stone and the feather, when you drop the stone and the feather from a height, you will notice that without the air being around it, you notice that both will land on the ground at the same time. Now let me use the crumpled and uncrumpled paper. If I should drop these two, drop them from this height You notice that, look at the uncrumpled paper, still flying. The air is offering an opposite reaction, like friction, to it, making it impossible for it to land, while the crumpled paper will land first. But when you remove this air, when you remove the air resistance, you notice that the two will land at the same time. So let's see the options there. Let me repeat the question again. A stone and a feather are dropped from the same height above the earth's surface, ignoring air resistance. Which of the following is correct? A. The feather will be blown away by the wind, while the stone will drop steadily. No. The stone and the feather will both reach the ground at the same time. Correct. C. The feather will reach the ground first. No. D. The stone will reach the ground first. No. The correct option here is option B. The stone and the feather will both reach the ground at the same time. Two of them will reach the ground at the same time because there is no air resistance. And I pray you go on, look out for other questions, study, solve, and watch out for our next video.